Okay, today we're looking at functions. A function can be a relation with x values, or the domain, and y values, or the range. I want you to think of a function today as a machine. Okay? As you put in those x values, the domain, put in those x values into the function. This is your function. You're substituting each of these domain values in for x. You're going to get out your y values or your range. So let's practice that. If this is the function, if this is the rule, and we're putting in these domain values, or in other words, remember domain is x, let's practice that. So here, for this first x value, -1, where we see x, we're plugging in -1. What do we get? 2 times -1 is -2 plus 3 is 1. Now let's plug in our next domain value. So 2, plug in 0 for x, plus 3. So 2 times 0 is 0, plus 3. 0 plus 3 is 3. And then our last domain value of -1, we've got 2, parentheses, 1, plus 3. 2 times 1 is 2. 2 plus 3 is 5. So for this function, given these domain values, our range values are 1, 3, and 5. We just found them by plugging in. So our ordered pairs, if we were to plot these points, ordered pairs would be -1 was the x. When we plugged in -1, we got a y value of 1. Our next ordered pair, when we plugged in 0 to our function, we got 3. And last but not least, when we plugged in 1 to our function, we got 5. So for this function, the domain and range is this. These would be the ordered pairs that we plot on a graph. Okay, so let's talk about function notation, how we notate a function. F of x means the same thing as y equals. So y'all have seen y equals for a while now. Now, instead, if that y equals, if that equation is a function, we're going to now start using the function notation f of x. Using f of x just shows that the equation represents a function. So since the equation, the one we just dealt with, y equals 2x plus 3, is a function, we can instead use, instead of y equals 2x plus 3, we can say f of x equals 2x plus 3. It just means that this is a function. This is a function of x. So, to find f of -1, we substitute -1 into the equation where we see x. So let's look at some examples. Find the range of each function for the given domain. So let's do what we just did. If we need to find the range of this function, if the domain is this, remember domain is the same thing as x. So we're taking these domain values, or these x values, plugging it in where we see x. So for the first one, we're finding f of -2, plugging in -2 where we see x. F of -2, the function evaluated at -2 is what that means. So for the first one, we've got -2 squared, +4 minus 3. +4 minus 3 is 1. Okay, let's find our next function value. Let's find f of 0. So if the domain is 0, plug in 0 where we see x. So 0 squared is 0, and 0 minus 3 is -3. Okay, the next one is f of 2. Find f of 2. So plug in 2 where you see x. 2 squared is 4, and 4 minus 3 is 1. And then last but not least, let's find f of 4. So plug in 4 where you see x. 4 squared minus 3. 4 squared is 16, minus 3 is 13. So if this is the domain, our range is all of these values that we just found, and putting them in order from least to greatest, -3, 1, we don't need to repeat it, and 13. Those would be our range values. Now, I want you to be aware that -2 goes with 1. That would be your coordinate, -2, 1, 0, -3, 2, 1, and 4, 13. Those would be your coordinates. This is your domain. This is your range. All right. If f of x equals x squared plus 4x, so this is a function, and g of x, this is another different function, g of x is 5 minus 3x. Find the following. Find f of -3. That just means we're evaluating this function f when x is -3. So we're plugging in -3 where we see x in the function. And in this particular function, that's in 2 places, here and here. So we're plugging in -3 into 2 different places. So following PEMDAS, I've got -3 squared, which is 9. Positive 4 times -3 is a -12. So we've got 9 minus 12, that's going to give us -3. So basically, f of -3 equals, in this case,